Alright, so just straight up reviewing for the progress check. So first question, it's asking, you got to fill in the blanks below with the correct response, knowing that MN is the mid-segment of triangle ABC. There are a few errors on this page. Just make sure you change this there. So remember, a mid-segment means that this MN side is half the length of the third side BC and also parallel to that side. So if it's half the length, if MN is 5, BC is 10. Perpendicular, this has nothing to do with mid-segment, so that's just a no. AB is not perpendicular to MN. They don't even look perpendicular. This is not a right angle at all. If BC is 24, same thing. That's double this. This should be 12. If AB is 20, even though AB is not a mid-segment, the mid-segment means that it actually cuts this in half. So AB is 20, and this is 10. Our CN is CN congruent to MB? Are these two congruent? Just because they're on opposite sides doesn't they are not congruent. Not necessarily. There may be a certain case where they are, but most of the time they are not. F is just asking for the official definition. What is the main relationship between MN and BC? This would mean MN is half of BC, and MN is parallel to BC. So definition of mid-segment. If AN is 17, and what's AC? Guess what? Double. 34. And last one, if measure of angle AMN, which is AMN, if that's 38, then what's ABC? Well, since these lines are parallel, because of the definition of mid-segment, this means that I now have corresponding angles which are congruent. So guess what? If this is 38, that's 38. So this is all thanks to the power of the mid-segment. Please be familiar with this definition. There is a confusing question about mid-segment. Not like this one. All right, here I have an isosceles triangle, and I have to solve for x and y. So with an isosceles triangle, it means that I've got two congruent sides, and I have two congruent angles. I need to solve for x first. So the reason why is because with y, I have an equation with x and y in it. So I either have to solve for y first or solve for x first. In this case, I need to solve for x first. So I could set these two equations equal to each other. 6x minus 25 equals 3x plus 5. If I wanted, I could use a more complicated equation. I could have used all three of these and see if they added to 180. That is more work in my opinion, but there's nothing wrong with doing that as long as the answer is appropriate. So you could have done this one. This is a lot of work. I'm just going to work on this one here. Your first step should be to, let's see, I don't need two x's, so I'm going to subtract the 3x from both sides. These cancel. 6x minus 3x is 3x minus 25 equals 5. Add 25 to both sides. Then I get 3x equals 30. I need to divide 3 on both sides. Cancel. X equals 10. Now that I have 10, I can plug in 10 here and use that 10 to help find the rest. So 4 times 10, because I plugged in the 10, plus 3y equals that, 6y plus 34. 4 times 10 is 40, plus 3y equals 6y plus 34. Subtract the 3 y's. 3 minus 3y is gone, so 40 equals 3y plus 34. I'm going to subtract 34 from both sides. That's gone. That's 6 equals 3y. I divide the 3. And I get 2 equals y, which means y equals 2. So I needed to solve x here first before y. That's because with the y equation, if I were to set up an equation, I have x in the way. But if I use the x equations, I don't have a y in the way. So it's whichever ones that you can solve for first. If you can solve x first, do that first. Here, again, lines are parallel here. So since they are parallel, that means I get 2 types of angles that open up. I have corresponding angles that are congruent and alternate interior angles that are congruent. So you'll need to use both of them. So you got to find all the missing things. I know that 4 is 61, so that's 61. Put a 61 there. I know that 14 is 29, so I'm going to put a 29 there. The easiest angles to always find are the vertical ones. That means the ones that are across. 61 is here, so it also must be here, the ones that are directly across, like that. That's 61. This must be 29. So 9 is 29, and 3 is 61. So after the vertical angles, next come the supplementary angles. Are there angles that add to 180? Yes. This one and that one must add to 180. In that case, I would subtract. 180 minus 29 is 151. That means this is 151 and this is 151. 10 and 13 are both 151. Continue with that. There's no more supplementary, no more vertical. This is where I need to start using corresponding and alternate interior angles. I do notice an alternate interior angle here. This 61 would match with the 8 here. So this is also 61. Meaning you got 2 parallel lines. On a line cutting through them, the angle appears on opposite sides. So that's 61 and 61. 4 and 8 are both 61. So that's 61. Well, if that's 61, then that's 61. Love vertical angles. And I need them to add to 180. So I do 180 minus 61, which is 119. 119. 119. 7 and 12 are both 119. After alternate interior, I could use corresponding. That's 29, which means that's 29. I guess these are also alternate interior as well. If that's 29, then that's 29. So 1 and 6 are 29. And then finally, I got 2 and 5 missing. Well, all 3 of these on top and all 3 of these on the bottom need to add to 180. So I will do 180 minus the other 2 angles. 180 minus 61 minus 29 being 90. So they are all 90. 90 and 90. So yes, parallel lines are wonderful. They let us do all these wonderful things. More parallel lines. This case, it's E and F are parallel. I need to find some of the missing information here. I need to find x, y, and an angle measure. They only gave me that 1 is 76. You always want to do vertical angles first. If that's 76, then guess what? That is 76. Because they're parallel, I'm allowed to use corresponding angles. 76 and this is 76. That's 76. And now I can use supplementary angles, meaning 2 angles that add to 180 to find the rest. 180 minus 76 is 104. So everything else is 104. 104. 104. 104. Well, great. 7's 104, so I have this one. I gotta find the rest now. 2. Well, 2 is 104, but it's equal to 4x minus 4. I can solve this equation. 104 equals 4x minus 4. You add 4 to both sides. Cancel. That's 108 equals 4x. Divide 4 from both sides. And x equals 104 divided by 4. That is, I have this written down, 27. So x equals 27. With y, same thing. 104, because that's 7, equals 3y minus 10. Add the 10 to both sides. That's 114 equals 3y. Divide 3 from both sides. That's 38 equals y. Which means y is 38. There we go. So again. Alright, this is where the dilations come in. Use the pre-image and image below to determine the following. First, I need to figure out which one is which. Where's the pre-image, the bigger or the smaller one? The pre-image, is the one that is larger. This is because it doesn't have the little apostrophes. It doesn't have the primes. So the ones with no primes are pre-image. The ones with primes are the image. So that's the smaller one. If it's going from larger to smaller, this is called a reduction. Since it's getting smaller, your scale factor needs to be a fraction less than 1, something smaller than 1. Well, how do I find that scale factor? The easiest way to find a scale factor is just to look at the sides. So how big is this side? This side is just 1. This side is 3. It's getting smaller. The formula for scale factor is always an image distance divided by a pre-image distance. Well, what's the distance on the image here? This r prime s prime is 1. This one is 3. So I would do 1 over 3. Please leave this as a fraction. Don't put 0.33333333. It's not going to be accurate, and it's not easy to work with. After this, the next question asks me to find the center of dilation. To find the center of dilation, I connect all the letters that are the same together. R and R prime. S and S prime. T prime and T. Q and Q prime. Where are they all going towards? They're all heading towards here. That is your center of dilation, which is 1, 2. Your center of dilation is 1, 2. All right. Another dilation. All right, this one, they've got a piece that's missing. Great. Pre-image and image to determine the following. The pre-image is the smaller one. The image is the larger one. So from smaller to larger. This is called an enlargement. Enlargement. First things first is asking me to find the scale factor. That's going to be hard because you see all these sides are diagonal, so I really can't measure any of these sides. So in this case, I will need to find the center of dilation. So to find the center, I connect C and C prime, D and D prime. Where do they all meet? A and A prime, even B and wherever it's coming from. They all go towards here. In this case, the center of dilation is 0, 0. So now what I'm going to do is, rather than use the sides, I'm going to use a distance from any of the corner points to the center of dilation. The easiest one to use is C, because it's like right, it's horizontal. It's always image over pre-image. Image over pre-image. So for image, the image is C prime. So how big is the C prime? That is 3. How big is the pre-image? 2. So image over pre-image, 3 over 2. Your scale factor is 3 over 2, or 1.5. In this case, you can leave this one as a decimal because it's a nice decimal. No repeating decimals, please. All right. Coordinate notation, that's something we've been doing all year. That means, how do I get from one point to the transformed point? What do I have to multiply to get from one point to the other? I need to multiply 3 halves or 1.5. So 1.5 x, 1.5 y. So that is my coordinate notation. Last thing it needs to define b prime, which is off the graph somewhere. I mean, you could estimate it, but that's not reliable. Best way to do is use what you use for the coordinate notation. What am I doing to the points? Multiplying it by x, multiplying it by 1.5, multiplying y by 1.5. So let's figure out what b is. Then we can use b to find b prime. B is 4, 4,8. B is 4,8. Well, if I want to find b prime, I need to multiply each of these points by 1.5. 4 times 1.5, you can just calculate it. That's 6. 8 times 1.5, 12. So, there we go. And I use the scale factor to find that point. We got one more dilation here. This one's a negative dilation. First thing I need to do is mark the points here. Thankfully, the center is at 0, 0. If it was not at 0, 0, it would be very difficult to perform this dilation. First, mark the pre-image coordinates. That's -6, -3. L is -3, -3. K is -6, -6. Now what I need to do, I'm dilating it by a factor of -2, meaning I multiply everything by -2. So that means m prime is -6 times -2 is 12. -3 times -2 is +6. The negatives will change to positives. L prime, if I multiply it by -2, I get 6 and 6. K prime, if I multiply it by -2, I get 12 and 12. So for this one, unfortunately, it does go off the graph. We'll have to deal with this one. Well, the first point is that at least on the graph is 6, 6. So let's do that. 6, 1, 2, 3, 4, 5, 6. That is L prime. M is 12, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's just say 12 is on the end of the x. And that's about there. So let's call this one M prime. And last one's K prime. 12, 12, 12 up here, and 12 up about there. Let's call this K prime. Since it's off the graph, it's not going to be quite perfect. But that should be the negative dilation. So it should be bigger, but appearing on the other side and essentially flipped over. The questions we got here then, what are the relationships between the sides and what are the relationships between the angles? This question definitely happened on a previous test. Well, we know the sides are proportional. And what does that mean? That means M prime, L prime, K prime's sides are twice as long as M, L, K. So the sides are twice as long. Why does this occur? Because it's a dilation. So this is because there was a dilation. If you want to be specific, dilation by a factor of 2. And what's the relationship between the angles? Well, with a dilation, the angles do not change. They're the same angles. The angles are congruent. The angles are congruent because dilations do not affect angles. Dilations only mess with the sides. They don't touch, they don't alter any of the angles. Right? Right, after this comes things all relating to similarity. So in the figure below, DF and EH intersect at point G, and they are parallel, these things. DE and HF are parallel. So, first question says, which similarity theorem or postulate may be used to prove that these triangles are similar? Well, remember there are 3 similarity theorems. There is side proportionality for similarity, side, and finally angle. They gave me nothing about the sides. Parallel does not mean the sides are equal. They don't even look the same. Don't even think they're the same here. This case, it's got to be angle. That's got to be my only choice. So the angle theorem may be used. I don't want to write angle. Just write AA. The AA theorem may be used. It should be used, actually. How would I use this anyway? Well, what angles do I know are congruent? Well, I know these are congruent because they're vertical angles, right? Since they're parallel, I got corresponding and alternate interior angles that I can use. And in fact, I can use these two, this and that, as alternate interior. I could use these if I wanted. Nothing stopping me from using those two. It's just these two are the first I saw. If 2 triangles are similar, what do you know about the corresponding side lengths? Well, if they're similar, we know the sides are proportional. We're throwing this word around a lot. So, if they are similar, then the sides are proportional. Finally, we need to prove that these triangles are similar. And all we do is angle. So this angle, we got to mark these two as congruent, these two as congruent, and then we're good. So to write a proof, first thing we need to do is talk about the givens. So statement, reasons. So, what we have been given here is that DE is parallel to HF. So DE is parallel to HF. That was our first given. So after our first given, what's the first thing we marked in the diagram? We marked that these angles were congruent. So what is this called? DGE FGH. So be careful with the naming. DGE is congruent to FGH. And these are because these angles are vertical. We're just going to call this vertical angles. Afterward, what's next? We can just use one letter, angle E and angle H. Angle E is congruent to angle H. And that's because they are alternate interior angles. Interior angles. Great, I have an angle, I have one pair of angles and another pair of angles. I have now satisfied angle. That means these triangles are now similar, not congruent. DEG is similar to triangle FHG. And this is just called angle similarity. Right? Similarity proofs are pretty short. Next here, consider this figure a given. PR is parallel to ST. Okay, PR is parallel to ST. So Maya states that triangle QST is similar to triangle QPR because of angle similarity. So they are similar. Which proportion illustrates that ST divides QP and QR proportionally? We're going to circle which one. So which proportion is representing that QP and QR have some kind of relationship? First one, QS over QP equals QT over QR. It's definitely A. It is absolutely most definitely A. It's showing that QS divided by QP is QT divided by QR. It's like cutting them, really. QT and T, this one here, the second one, QT over TS and TR over RP don't work there. QT over TS and TR over RP, these aren't working. If I said QR over RP, QT over TS, QT over TS versus QR over SP, that doesn't mean anything. The rest of these actually don't really mean anything. So this actually ends up being the only one that works. So if we had an equation and you had to solve a problem like this, this is the only proportion that you would be allowed to use. All right, this one's kind of tricky. All right. Given triangle ABD with altitude AC, altitude just means it makes a 90-degree angle to the ground. Angle ADB, that's here. That's 37. Show that triangle ABD, which is the big one, is similar to CAD, the medium one, and CBA, the smallest one. Show that they're all similar. They gave me nothing about the side. This has to be angle similarity. So right now, here's something we can do here. Let's figure out all the missing angles. That's 37, that's 90, then what does this have to be? Subtract 180 minus everything. 180 minus 37, oops. 180 minus 37 minus that 90, and it'll give me the little angle on top. That means this has to be 53. Well, if these two have to add to 90, what's 90 minus 53? That's 37. And then finally, this has to also be 53. So I need to show all three triangles are similar. It's a little bit difficult to see all these triangles all jumbled into one picture. So I'm going to separate these into three different triangles. So let's start with ABD. Let's just do ABD. ABD. That's this really big triangle. Let's make it upright. So ABD. A is the right angle in this case. A. B is the here. And D's up here. So let's copy the angles. B is 53. And this angle D part is 37. So this is the big triangle. Let's draw CAD. CAD is the medium triangle. I want to draw them, we can just kind of draw it out what's here. CAD. So we can draw CAD now. Oof, that's pretty bad. Whatever. So CAD D, that's 37. That's 53. And the last one, CBA, which is this little triangle right here. CBA. In this case, that's 37. That's 53. So what do you notice about all these three triangles? Don't they all have the same two angles? That. All three triangles are similar by angle. Because if you take each of these triangles and draw them out individually, they all have the same two angles. So they are all similar by AA. We got some more proofs here. Note there was an error here. That needs to change to AB. That needs to change to CE. So given that AB is parallel to ED, let's draw that. AB is parallel to ED. And AC is congruent to CE. Why don't I change colors? We like that. AC is congruent to CE. We want to prove the triangles are congruent. Well, I have one thing. What is the easiest thing to use right now? Easiest thing is always vertical angles. They're vertical, therefore they're congruent. Because they're parallel, I can also use alternate interior angles. I liked A and E. I could have used B and D and have angle side. I just like them being together, so there's two ways to prove this. So, great. These are all marked. Let's start our proof. Statement, reasons. First thing to do, let's state our givens. AB is parallel to ED. And that is a given. AC is congruent to CE. That is also a given. And now let's fill out the rest of the information. After I marked the diagram, what's the first thing that I stated? I used vertical angles, right? Angle, we can't call this C and C. We have to use the three letters. A, C, B, and E, C, D. So this is angle ACB is congruent to angle ACB, ECD. And this is true because they are vertical angles. Afterward, we use the alternate interior angle. So because these angles are in the corner, you can just use one letter. Angle A is congruent to angle E. And this is true because they are alternate interior angles. So let's take a look at what this triangle similarity theorem is. I have an A, an angle, a side, and an angle. Angle, side, angle. This is the angle, side, angle postulate. So now we can prove the triangles are congruent. Triangle CAB is congruent to triangle CED. This is because of the ASA. Angle, side, angle postulate. You could have also used angle, angle, side. It's whichever one you see first. Here we go. Proven. Here I have this. So let's mark the information in the diagram first. Well, what does it want me to prove? It wants me to prove that two angles are congruent. It wants me to prove these angles are congruent. let's see if the information helps us do that. BC is congruent to CD. AC bisects BCD. If it bisects the angle, that means it cuts this angle in half. Right? Using this information, is there any way for me to get from here all the way to there? Unfortunately, there is not. This is one of those CPCTC proofs where you have to prove the whole triangle is congruent first before you can talk about any of the other things. So let's just prove the triangle is congruent. What thing is the same on both? Everyone's favorite, reflexive property. So AC is congruent to AC. So let me just mark a note here. We are not proving the triangles are congruent. Proving that the angles are congruent, not the triangles. But I have to prove the triangles are congruent first in order to get these angles. All right, so let's just start writing our long proof. First things first, we need to write our givens. Statement, reasons, our first given, BC is congruent to CD. This is because it is given. Same thing here. AC bisects angle BCD. This is also a given. Let's take a look at what we did. Well, we said that since it bisects the angle, it cuts these two in half. That's because it was a bisector. So it's the definition of angle bisector. So let's call this angle BCA is congruent to angle DCA. This is because of the angle bisector. If it's just because, it just means definition. Definition of angle bisector. All right. Last color I did not use. I did not use the green. That's the reflexive property side. AC is congruent to AC by the reflexive property. Reflexive property. I don't feel like writing the whole word. Reflexive property. Now, what do I have? I have an example of, what is this? A side, an angle, and a side. This is the SAS postulate. I have now proven that triangles are congruent. So, triangle ABC is congruent to triangle ADC, and this is by the side, angle, side postulate. Okay, SAS. Now, what I'm trying to prove is I'm trying to prove these angles are congruent, not that the triangles are congruent. So if you go here, you're not done. You need to use this information. If I've proven the triangles are congruent, that means all the parts inside the triangle are also congruent. So once I've proven the triangles are congruent, I have now allowed myself to essentially say that everything else is congruent. So I can totally say this now. Angle BAC is congruent to angle DAC. And this is, we call this CPCTC. Corresponding parts of congruent triangles are congruent. Basically means if I prove the triangle's congruent, then all the parts inside must be congruent as well. All right, so we're done with proofs. Got a few more to go. Oh my goodness, similarity. All right. Are the parallels of triangles shown similar? And then if so, we're going to talk about which ones work. Notes. AB and DE are parallel. Okay, let's mark these as parallel. If they're parallel, what do I know about the angles here? I know that I have, these angles are corresponding. Are there any other angles that are the same in both triangles? Well, if you notice, this small triangle has a corner of C, the large triangle also has a corner of C. So this is an example of angle-angle. So yes, they are similar by angle-angle. Yes, similar by angle-angle. All right, similar by angle-angle. What about this one? I have 3 sides. Nothing about the angles. Let's check if the sides are proportional. 15 divided by 5, that's 3. Easy. 18 divided by 6, that's also 3. Easy. 24 divided by 7, that's definitely not 3. That's actually 3.429. So I have 2 sides that are proportional. The third side is not. It's off. So they're not similar. So no, they're not similar. Because they fail SSS. Or because side proportionality fails. So unfortunately, not all 3 sides are proportional. 2 of them are good, that third one is bad. All right, we got a word problem here. Mr. Walderhog's pretty tall, but Mr. Chenier is even taller. Mr. Walderhog wants to know how tall Mr. Chenier really is, but can't accurately measure his height. So we have this diagram to figure out how tall they are. There's 2 equations you could use here. I could use this one. Height over height equals shadow over shadow. So height over height. So I could do Chenier's height over Walderhog's height equals Chenier's shadow over Walderhog's shadow. 41 over 38. So this is one equation I could use. Or I could have done this one. X over 41, the height over its shadow, equals 76 over 38, height over shadow. So regardless of which one you use, you notice you still have to multiply x and 38 and 41 and 76. So regardless of which one you use, you'll still get the same answer. So let's do this, cross multiply. I'm just going to do the one on the left. X times 38 is 38x. 41 times 76, that's a very large number, which I've already written. That is 3116. I divide by 38 from both sides. X equals, that's 82 inches. All right. Set up a proportion equation and then solve it. Right. Last one, here comes the trigonometry. When we are doing trigonometry, oop, I do not want to shut down. Remember, we use this, so what? You do not need to memorize this. This is provided on a little formula sheet. So let's start with, let's figuring all these out. Sine of A. So sine is what over what? S. O, opposite over hypotenuse. Opposite of A is 12. The hypotenuse is 13. Cosine of A. The adjacent is 5. The hypotenuse is 13. For tangent of A, the opposite is 12. And the adjacent is 5. What if I'm going from sine B's perspective? From B's perspective, the opposite is now 5. So sine opposite hypotenuse, 5 over 13. Cosine of B, adjacent is 12 over 13. Adjacent over hypotenuse. And tangent of the opposite, 5 over adjacent 12 is 5 over 12. All right, not too bad. So what do we notice about sine A and cosine B? Sine A and cosine B are the same. What about cos A and sine B? They are also the same. They have the same value. Right? Okay, that's fun about sine. What do you notice about tangent A and tangent B? Well, you flipped the fraction, right? So they are reciprocals. So if they are reciprocals, this is actually how we write reciprocals. This means so tangent of A equals 1 divided by the tangent of B. Dividing something underneath 1, so 1 divided by a fraction does flip it. So remember, be aware of this notation here. What's tangent A times tangent B? What happens when I multiply these two together? Then I get 12 over 5, tan A, times 5 over 12, which means multiply 60 over 60, which is 1. If you multiply tangent of A and B, they cancel out to be 1. What about G, sine of C? The opposite of C is 13. The hypotenuse is still 13. So I got 13 divided by 13, which is 1. Now looking at the diagram, is it possible to determine cosine of C? C, I need the adjacent, right? Well, both of them are adjacent, right? Neither of them are the hypotenuse. So I can't pick either one. So I can't do cosine C because it has two adjacent sides. I can't use tangent either because I also have two adjacent sides. So for both of them, can you determine either of them? You cannot. So they both have the same answer. So why don't I just draw an arrow to both? No, because there are two adjacent sides. All right. Here's a fun thing here. So, use what you know about the relationship between sine and cosine to complete the statements below. Sine of 30 equals cosine of 60. Remember, these two angles must add to 90 in order for sine and cosine to be equal. If cosine is 45, sine has to also be 45, because 45 and 45 make 90. Let's pick a really boring one. How about sine of 1 degree and cosine of 89 degrees? They also have to add to 90. So the notation to actually represent this is this. This is saying sine of A equals cosine of 90 minus A. Now, what exactly does this mean? Let's use this and use the first one to represent it. So what is A in the first example? A was 30. So what happens if I plug 30 into this weird formula here? Sine of 30 equals cosine of 90 minus 30. So that means what? Sine of 30 equals cosine of 60. And again, both angles add to 90. So this is just the formula representing this pattern here. So that's because they both will add to 90. All right, and then 17 here. Now before we start 17, I need to use sine and cosine in a calculator. This is a geometry class, meaning we need to use degrees, not radians. So what I need to do first is check your mode. My mode's in radians. I need to go down and change it to degrees. Oops. There you go. So change it to degrees, otherwise you may get some negative angles and negative sides, and that is not fun. Alright, so for 17, Trent's tree trimmers, funny, uses a 100-foot ladder to get access to tall trees. A local business owner calls and needs a tree that stands 95 feet tall trimmed. So let's label the diagram. Well, the tree is 95. The ladder is 100. So there's the diagram. We can use this. Now it says, safety regulations state no ladder should stand at an angle greater than 80. Greater than 80 is bad. So no greater than 80. Will Trent violate safety regulations if he completes the request? So we need to check what this ladder is. What is this missing ladder? So let's just label this as theta. What's this missing angle? Well, 95 is what side compared to the angle? That's the opposite side. 100 is the hypotenuse side. O and H. O and H. Which of the three trig functions could I be using? O and H. O and H is clearly that one, sine. So I need to say sine of theta equals the opposite, which is 95, over the hypotenuse, which is 100. Now I'm trying to solve for the angle, right? I need to get rid of the sine. The way we learned to remove the sine is by using sine inverse. So I need to use sine inverse, and we're going to put in this thing. 95 over 100 should give me theta. So turn it on. Sine inverse of 95 divided by 100 is, oops, not 1,000. 71.805. 71.805. So this is where we need to actually find the value here. So, did he violate safety regulations? It says it can't be greater than 80. This is less than 80, therefore it's pretty good. So, he doesn't violate. He doesn't violate the regulations. Since the angle is less than 90. Not 90, since the angle is less than 80. Part C. Trent decides to buy an adjustable ladder. If Trent wanted his new ladder to stand at an angle exactly 80 degrees horizontal to the ground, what height would he need to adjust his ladder to? Now in this case, he wants it to be exactly 80. Now we have a new diagram. So he wants his angle to be 80. 80 degrees. The tree's still 95. In this case, if he has an adjustable ladder and wants to be exactly 80 degrees, what would he need to adjust his ladder to? Well, according to 80 degrees, and I forgot, you gotta mark that 90. If this is 80, 90 is still the opposite. 95 is the opposite. X is the hypotenuse. O and H, I'm still using sine. So sine of 80 equals opposite, 95, over hypotenuse, X. This is one where I have X in the denominator. So how do I get rid of X in the denominator? Multiply X to both sides. This cancels. I'm left with X. Oops. X sine 80 equals 95. Now I need to divide sine of 80 from both sides. Left with what? X equals 95 divided by sine 80. All right, I'm probably getting a decimal. When you have sine and cosine, things end up being decimals. So 95 divided by sine 80. 80. Not hitting the zero. There we go. Oh my goodness. 96.465. Let's just round it to 6 decimal places. 96.466. There we go. Right. Oh, last page. Finally, I can go home. We're going to solve for x, y, and theta in the triangles given below. So what have they given me? They've given me just a 28. So let's use 28 as our base. The opposite is y. The hypotenuse is this. The adjacent is x. Oh, let's just solve for x first. X is the adjacent over the hypotenuse. So let's do this. Sine of 28 equals a, which is x over 10.625. So to solve this, I would simply just multiply this decimal to the other sides. So then what do I got? This cancels out. I'm left with x equals 10.625 sine 28. This can go into our calculator. So what was it? 10.625 times sine of 90, not 98. What was the angle? The angle was 28. Enter. That gives me 4.988. That's x. Now I need to find y. So to get to y, that's the opposite and hypotenuse. The opposite is, oh wait, I made a mistake here. That should not be sine. Sine is the opposite, right? That means, that means this has got to be y. So y equals, looks like I found a y first. So yeah, sine is opposite. It looks like I was trying to solve for x, but since it's O, sine there. That's y, my mistake. Now we're going to solve for x. X is the adjacent. So x means I got to use cosine. So cosine of 28 equals adjacent x over hypotenuse 10.625. I really don't like this decimal. Do the same thing. Multiply 10.625 on both sides. These cancel. X equals whatever this junk is. If I put this into the calculator, I'm going to be lazy. Oops. So I'm going to second, and I'm just going to hover over and just put cosine instead. Should get 9.381. All right. The last thing it asked me was to find its theta. Well, I know all three have to add to 180, right? So I can simply just do this. So what happens to theta? Theta has to equal, what? 180 minus the other two. Minus 90 minus 28. If I do that, I'm going to get 62. So theta is 62 degrees. Great, I found solve x, y, and theta. Now let's solve these three. So Koto again. This is the opposite. That's the hypotenuse. That is the adjacent. Now I have the adjacent. I'm missing the other two sides. Let's try the first one without messing it up. So I'm going to find the opposite side. Opposite. Do I have the h? No, I can't use these two. But I do know the a, so I can use O and A. OA is tangent. So tangent of 32 equals the opposite x over the adjacent 13. To solve, multiply 13 to both sides. Cancel. X equals 13. Tangent of 32. I did this in the calculator already. That is 8.123. That's x. I do need to find y now. So I could use a and h. And in that case, a and h is cosine. So let's set up a cosine equation. Cosine of 13 equals, not 13, 32. I'm very tired. A, 13 over y. Multiply the y to both sides. Cancels here. Y times cosine 13. Not 13. I keep saying 13. 32 equals 13. Divide cosine on both sides. Cancel this out. Y equals 13 over cosine of 32. I did this on the calculator already. Y is going to be 15.329. And last thing he asked me to do is to find the theta. Well, I can use what I did on the previous page to find theta. Theta equals what? 180 minus 32 minus the 90, and now I can finally get that last one. If I subtract these all together, I get 58 degrees. All right, I am done.